Windows XP performance enhancements. Now, throughout the years, people have complained just how long it takes for Windows operating systems to start. Even on fast computers, Windows 98 and Windows 2000 can easily take more than a minute to boot up. Now, thankfully though, Microsoft has addressed these issues and really has turned things around to make Windows XP their fastest operating system yet. Now, what we're going to cover in this video are the key changes that were made in order to boost the performance of Windows XP. And we have a summary of those changes that are listed right here on the screen. Now, first off, Microsoft has enhanced the performance of Windows XP by really dramatically decreasing the system boot times. Additionally, Microsoft has also been able to decrease application launch times quite well. And Microsoft has done a very good job of allowing Windows XP to manage its memory much better than previous operating systems. So let's take a closer look at how they've been able to fulfill these tasks in Windows XP. Now, one of the very first things you're going to notice about Windows XP right out of the starting gate is just simply how much faster a computer boots with Windows XP compared to the previous Windows operating systems. Now, during the development phase of Windows XP, Microsoft had set some very high boot goals for this new operating system, and we have those boot goals laid out on the screen right here before us. Now, what you'll find is this: computers that have newer hardware, such as a Pentium 2, 450 megahertz or higher, will be able to boot in 30 seconds or less. That is right, 30 seconds or less. This is not a typo. But the fun does not stop there. Keep going here. Check this out. Windows XP will be able to resume from hibernate mode and standby mode in unbelievably short times as well. Let me just talk about these two modes just for a second here. Now, what hibernate and standby mode are used for is to place a computer, such as a laptop, into a low power state to help your laptop to conserve battery power. The main difference between the two is that hibernate mode will use some hard drive space and take the data that's in RAM and it will place it into that hard drive space, whereas standby mode won't use any hard drive space at all. So in XP, when you're resuming from hibernate mode, check this out: 20 seconds or less. 20 seconds or less. And then standby mode is 5 seconds or less. I have actually seen on newer laptops where Windows XP has been able to come out of standby mode in 2 seconds or less. Blink and it's there. It's just incredible times. So, we've got some amazing numbers here, but how did Microsoft actually achieve these numbers? Well, they've achieved these goals here by making some very specific changes to the system boot process. And let's take a look at how they've made these changes next. The Windows XP fast boot times are the result of making some changes and additions to the boot process. And that can be broken down into these three categories that we see in the screen here. Now, the first significant change is an improvement to the bootloader in Windows XP. And the bootloader is a file called NTLDR. And what this does for a living is that it loads key system files during the boot process. And Windows XP loads these system files more efficiently by reducing the time that it takes to find these files on the hard disk. And the end result of that is the bootloader in Windows XP is about 4 to 5 times faster than the bootloader in Windows 2000. So a significant speed improvement right there. Additionally, there are many files that have to be loaded from the hard drive into RAM during the boot process. And Microsoft has added a new function to help make that a little faster. Now, what happens is Windows XP will grab the files that it needs from the hard drive before they're actually needed. And that function is called prefetching. I'm going to go down and get the files before I need them from the hard drive. So I'm going to prefetch them. And this essentially eliminates the time delays of waiting for these files to load from the hard drive into RAM, which is nothing to sneeze at. That was a significant time delay. So we've got a big improvement right there. And things get even better here. The prefetching function is made more efficient by another feature called disk layout optimization. And what this will do is two things. First off, this process is going to lay out files that are prefetched in a contiguous format, meaning that the files are strung together end to end without any breaks. So if I've got files, it's in one nice contiguous format right here, as opposed to a discontiguous format where I've got some breaks in between where my files are located. This is less efficient. It's harder to find my files if I got to search all over the place for them. Another thing that the disk layout optimization will do for you is it's going to lay these files out not only in a contiguous format, but it's going to lay the files out on the outer, more dense area of the hard drive. So let's pretend that this circle is our hard drive, and the disk layout optimization is actually going to take all these files, the prefetched files, and some other application and common files, and it's going to arrange all those files out into the outer edge of the hard drive versus randomly sprinkling those files around anywhere on the disk, which makes it much harder for the head in the hard drive to be able to find files if they're just randomly tossed about. By putting those files in the outer edge of the disk in a contiguous format, it really speeds up the process of finding the files, of prefetching the files, and that all ties together here into a nice bundle here. So we've got these three components that all fit together in a nice neat package, which results into these fast boot times. So I've laid out files in a contiguous format, strung together at the outer edge of the disk, and I'm prefetching these files before I actually need them, which results in decreased read times for loading these files, and the end result is a nice fast boot time. So we've got some pretty cool stuff here, to say the least. Now I've got a couple of important points about when the fast reboots actually kick in, because they don't happen right away. On the first reboot following the installation of Windows XP, it's a little slow. You're not going to experience the 30-second or less reboot time frame that I've been raving about here. And this is simply due to the fact that Windows XP hasn't had the time yet to observe which files should be prefetched. So the first reboot is a little slow. The second time you reboot the computer, what happens is Windows XP is going to observe and log the files that are required during the boot process, and this in turn is going to build its list of prefetched files, or files that should be prefetched. So on the third reboot, with this list in place, Windows XP is going to experience a 90% speed increase in boot times. So you'll get very, very close at this point on third and subsequent boots following the installation of XP of those really fast boot times. Now the remaining 10% speed boost won't occur until Windows XP has had a chance to perform a disk layout optimization of these prefetched files and common files and application files too. Windows XP does a very good job of speeding up application launch times by using prefetched files and disk layout optimization. Now, this optimization only takes place once every 3 days, so bear that in mind. Now, thankfully though, this optimization only occurs during an idle period. And I say that because what happens is the built-in disk defragmenter is actually responsible for performing this optimization, and that certainly slows down the computer a little bit, and we don't want that to kick in while we're working. So what will happen is once every 3 days, Windows XP will look for an idle period of anywhere between 5 to 30 minutes. So meaning that if your computer's been idle for 5 to 30 minutes, an idle time process will kick in to start the optimization process. So we have our rules of 3 here. Not going to do the disk layout every day. It only occurs once every 3 days. and we're not going to experience the really fast boot times until our third reboot. So please bear these points in mind as we go forward here. The disk layout optimization that we just talked about is a very important piece in the fast boot equation, as it directly affects the prefetch files, which in turn affects our fast boot times. Now I'd like to share a couple of tips with you regarding this disk layout optimization process. First off, Windows XP knows which files should be optimized during this process by looking to this file right here, layout.ini, which is located in this directory, Windows Prefetch. In addition to this file, there's another key file inside the Windows Prefetch directory, which is this file right here, ntos boot-b00dfaad.pf. Say that 10 times fast. The PF represents a file type called a scenario file type. And what I'd like to do now is take you to these two files and talk about this process a little more. So let's just minimize this, and your prefetch directory will be located in your system root directory, which is typically in your C partition. So we're going to go to our C partition by clicking on Start, My Computer, and here we go. Double click on C, we'll scroll down, and here's our Windows directory. And the prefetch folder is a normal view folder. It's not a hidden system folder, so you just find the prefetch folder, double click it, and voila, here we are. So all the files that you're looking at right now are the scenario files that are referred to. And if we scroll down a little bit, we find our layout.ini file. So how this file is actually built and maintained is through the prefetcher service. And the prefetcher service will once every 3 days look to all these scenario files and find out which items within the scenario files are used most commonly. It's going to go through and what's called parse through the scenario files. And the files that you use most frequently for applications, common files, all the prefetch files that we've talked about will be included in layout.ini. So let's take a look at layout.ini. Just double click on it to open the file. And if you notice, the files that I've highlighted here are key system files, which are actually prefetched during the boot process. So what happens is the task scheduler is actually responsible for going through all the scenario files once every 3 days, finding out which files are used most often, and adding those files to layout.ini. The task scheduler will in turn then tell the built-in disk defragmenter to open layout.ini, find a listing of all these files, and then to optimize all the files that are listed and place them in the contiguous arrangement on the outer edge of the disk. So the takeaway point here to recognize is that, number one, the task scheduler is used to perform this process in tandem with the built-in disk defragmenter, and number two, if you were to ever disable the built-in task scheduler, that would in turn stop the disk layout optimization, which in turn is going to affect your fast boot times. So make sure you don't disable the task scheduler service to ensure that you've always got optimal disk layout. So let's close out of here, and if we scroll down just a tiny bit, we'll see our key file that's used by the operating system to prefetch the system boot files. ntos boot-b00dfaad. It's right here. So what I'd like to do right now is go back to our slide and share a couple of tips with you on how you can actually manually trigger the disk layout optimization process. You don't have to wait the once every 3 days. So let's go back to our slide now and take a look at a couple more tips for you. If you'd rather not wait for 3 days to go by before the disk layout optimization occurs, or if the task scheduler had actually been disabled, there are two methods, as I mentioned, you can use to manually force the disk layout process to occur. The first method is to have a DLL call to the process idle task API, which in turn will kick off the disk layout optimization process. This is very easy to do. We'll do that in just a sec. Or the other option is to use a utility provided by Microsoft called bootviz, which is used to do two things. Number one, it's used to perform a boot trace of all the activity that occurs during the boot process. And number two, it's also used for optimizing the boot process to increase fast boot times. So let's have some fun with these two methods and see how they work. Okay, how about we start off with our first method to manually perform a disk layout optimization, and that is to tell the process idle task API to execute right now versus waiting the once every 3 days to execute. So how we're going to do that is by typing in a series of commands. So what you might want to do right now is to pause the video, get a pen and paper to take some notes about what we're going to do next. Okay, with your pen and paper in hand, the next thing that we're going to do is open up a run command, and that's done simply by clicking on the start button, then click on run. That opens up the run command dialog box, where first we're going to type in run dll32.exe space, then we're typing in advapi32.dll comma no space uppercase P. This is case sensitive, so do watch out for that. Then we're typing in the word process. Then we're typing in the word idle with an uppercase I, DLE. Then we're typing in the word tasks with an uppercase T. And there we go. And that's all there is to it. Just simply type in that command whenever you want to force a manual disk layout optimization. The next step we have is just simply to click on the Okie dokie button. So here we go. Now this is going to run in the background, and what's happening here is what we talked about before. The task scheduler is telling the built-in disk defragmenter to go into the Windows prefetch directory and look at layout.ini to do the disk layout optimization. So what's happening right now is the disk defragmenter is just simply parsing through that file, meaning it's looking at every single entry, every file that's listed there, and it's moving all those files, the prefetch files, application files, everything we've talked about, to the outer edge of the hard drive in that contiguous format. And that's going to result in a faster boot time. So how do you know it's actually going to run faster? Well, you can take my word for it, or we can get some empirical evidence. We can use our next tool, the bootviz.exe executable supplied by Microsoft, to monitor the boot activity, and it's also going to show us the actual amount of time that it took for the computer to boot. So let's take a look at bootviz next. Bootviz is a tool that's supplied by Microsoft. However, it's not actually included with Windows XP. So the first thing that we actually have to do is download this tool from Microsoft's website. Very easy to do. Just going to their main home page. So we're going to click on Start. Then we'll click on Internet Explorer. And then we're going to Microsoft's main home page, just www.microsoft.com. And from here, we'll just use the search engine right off their main home page to type in bootviz.exe. That's all. And just let her rip, search for that. And that brings up a search result for a download link for bootviz.exe. Let's click on that link right now. And that redirects us to a hardware development platform page. What you might want to do actually is pause the video right now so you can jot down the direct URL to where you can download this tool from. Now we're going to scroll down here just a tad, and here we see a downloads link. Just expand this, and here's our tool. As you see here, it's just a very small tool. It's a single file, 329K. So we're just going to download this to our hard drive. You can save it to anywhere, it really doesn't matter. So let's just click on Save. And we're done. So let's close out of Internet Explorer and go to our hard drive. Let's just click on Start, My Computer, go to our C drive, and we had saved it to the root of our C drive, and it's just a little self-extracting file, so we're just going to double click on this. And I'm just simply going to save bootviz to the root of my C drive. So let's unzip this, click on Okie dokie, close, and here we go. So we're all ready to fire this puppy up and see how it works. So to begin with, simply double click on the bootviz executable to launch the application. And bootviz essentially does two things for a living. Number one, allows you to perform boot traces, and number 2, to optimize the system for fast boot times. So let's look at option number 1. First off, to perform a boot trace, you have to choose the categories that you'd like to trace from the left-hand side. You can choose one or all the categories, doesn't matter. But for example, if you want to see actually how long it takes for the computer to boot up, you must choose the boot activity category. You might want to choose the other categories though if you're trying to troubleshoot where any bottlenecks could be occurring during the boot process. So this is a very valuable tool for boot troubleshooting measures. And to actually start the boot trace process, the next step after you've chosen the appropriate categories is simply to go to the menu bar and then choose Trace from the menu bar, and then either choose Next Boot or choose Next Boot with driver delays. It's best to choose Next Boot with driver delays to see if it's taken an exorbitant amount of time to load drivers, which in turn affects the amount of time it takes to initialize devices. So we're going to choose the second option here, and it's telling me now that this dialog box that once you click on the Okie dokie button here, BootViz is going to automatically restart the computer. It's going to trace the boot activity, and it's going to save that information to this file that we see right here. So what I'm going to do right now is that I'm going to pause the video, and I'm going to let BootViz restart the computer to perform its trace of the boot activity, and we'll pick up where we left off once the computer reboots. Okay, the computer has now restarted, and BootViz is in the process of taking all the information that it had traced during the boot time, and it's saving that information into this trace boot file. And as you see now, BootViz is automatically opening up the boot activity trace file, and it's going to display that information in this graphical format in these charts on the right hand side. So the first one gives you a lot of information. The boot activity chart shows us several things that we've talked about already, such as the prefetching category, and we see in this situation where the computer took 9.04 seconds to go to the hard drive and grab the files that it needed before it needed them, in a total of 9.04 seconds. But hey, let's use this to actually see how long it took to boot the computer up. So we're going to scroll over to the right hand side here just a tad, and in this situation it took the computer exactly 25.58 seconds to boot up. Woohoo! Not too shabby. Certainly beat Microsoft's 30-second goal there. But hey, let's go for the gusto and see if we can shave off a couple seconds off that. So we're going to use BootViz to optimize the disk layout to see if we can make this puppy run even a little faster. And we do that by going back up to the Trace menu, and from here you choose the option at the very bottom, which is Optimize System. Now when you choose this option, be aware that it's going to reboot the computer automatically, as opposed to when we chose Next Boot and driver delays. That option brought up a dialog box saying when you click on the OK button, it's going to reboot. When you choose Optimize System, it's automatically going to reboot. So what I need to do right now is I have to stop the video and allow it to do the optimization. Then we'll pick up where we left off once the computer reboots. Okay, the computer is rebooted, and you see now that BootViz is in the process of optimizing the system. It's performing the disk layout optimization, and you can see here in the background that it's laying out the files in the optimal manner to increase system boot times, and this typically takes between a minute to 3 minutes depending on how many files it has to actually move out to the outer edge of the hard drive. Now once this is done, it's not actually going to fire up BootViz and bring up the charts that we saw before. To actually see if there's any speed increase by performing this optimization, you'll have to go back into BootViz and perform yet again another trace. So we're going to do that next. Okay, the optimization has finished. Let's fire up BootViz and perform another trace. Remember, BootViz is just on my hard drive, so we're going to start my computer. It's root of my C partition, and let's scroll down here a little bit. Double click on BootViz, and we're going to perform another trace to see if the optimization that we just did a second ago actually made an improvement. So let's do that right now. And I'm going to have to pause the video here to allow the computer to reboot, and when it comes back up, we'll see what happened. Okay, the computer has now rebooted and it's saving its information to the trace file, and this will just take a second, and BootViz will boot up again, and we'll see if the optimization actually made a bit of a speed improvement. So keep your fingers crossed and drum roll, please. Okay, let's see what we got here. Okay, let's scroll over to the right hand side. And look at this, ladies and gentlemen, the boot was done in 20.03 seconds. Holy cow. So, as you see here, the optimization does actually make a difference. We shaved off close to 5 seconds of time there. Not bad at all. So as you see here, BootViz is an excellent tool to help you optimize the system when you need to. Additionally, before we leave this, let me show you a couple of other tips about this tool here. First off, as I mentioned, you can use this as a troubleshooting tool to help identify where bottlenecks might be occurring during the boot process. So for example, if your computer is taking maybe 40 to 50 seconds or longer to boot, you could see maybe if your CPU usage is pegged at 100% across the board for the entire time, maybe your CPU just isn't up to snuff, or maybe your CPU is fine but your disk is just simply too slow and it just can't handle the task for prefetching in the optimal time period. So you can come down here and see if the disk utilization numbers are at really high levels, 80 to 100% across the board. You can also use this to see how long it's taking for drivers to load and other processes to load here. So you can also use this tool here to zoom in on a very precise period of time to see exactly what is loading. For example, if we go to the CPU usage chart here, I can use any one of these charts and select a time period and find out very granular information for that time period to see exactly what is being loaded. For example, if I hold down my left mouse button, I can draw a little window over a period of time that I choose, and then you release your left mouse button and that creates a window of time, if you will. And if I right click on that window of time, voila, it gives me this little context menu to choose from. So let's choose an option from here, and that brings up a table that shows me a lot of the system drivers that are trying to load during that time frame, and in this situation the amount of CPU usage time that was consumed by these drivers being loaded. So if you notice here, the HAL, the kernel, WinLogon, many essential system files are being loaded during that process and the amount of time. So this is an excellent tool to help you identify where bottlenecks could be occurring and exactly what is the cause of the bottleneck as well. So I highly recommend using BootViz to optimize the disk layout for fast boots and for troubleshooting the boot process itself. So I hope you enjoyed this, and I highly recommend using BootViz for these tasks. The system optimization not only affects fast boot times, but also affects application launch times as well. Applications running in Windows XP will launch faster, also due to prefetching and disk layout optimization. The applications that are used most frequently will also be added to the layout.ini file that we talked about, and their files will be optimized just like the prefetch files used during the fast boot process. So applications in XP are going to get a really nice speed bump there as well. Now lastly, Windows XP's performance is substantially enhanced by many improvements that have been made to the memory manager. Now the memory manager does a much better job on Windows XP of allowing some applications to use less memory, which in turn allows for greater scalability, which in turn is going to allow for better performance. An example of this is if you have Internet Information Server running on Windows XP, Windows XP will use substantially less memory, which in turn is going to allow it to serve more pages, more web pages. Also, a redesign to some parts of the memory manager allow it to cache memory more efficiently, which is going to significantly reduce the input-output transactions to and from memory to the hard drive, which in turn is going to translate just to a much faster operating system. And lastly, Windows XP allows for almost a 1 gigabyte area of virtual contiguous space, which allows for improved terminal server performance, which you actually now have on Windows XP, which we'll see in a couple of other videos. And it also allows for giant driver mappings, which benefits video drivers to let them run more efficiently and thus more faster. So all these changes really translate into a faster and a more stable operating system than we've had in the past. So lots of changes have occurred in Windows XP, to say the least, to help improve performance. We've seen how Windows dynamic self-tuning mechanisms such as prefetching and dynamic disk layout have combined with the memory manager enhancements really make Windows XP the fastest Windows operating system yet. I hope this has been informative for you, and I'd like to thank you for viewing.